Hi Swadika, my name is Lakshman Gautam. I'm presenting this presentation and recording video for my mini projects in artificial intelligence, and the subject or topic which I have selected is Constraint Satisfaction Problem CSP. Okay, let's begin. What is CSP? CSP is a abbreviated as a CSP from the Constant Satisfaction Problem is a general purpose algorithm. It is widely used in the different variety of computer science problem, such as map coloring problem, which I have listed in the right side of the slide, where we try to apply the different color on the border adjacent state or province of the given map. Here we have we can see the we try to apply the different color in the map of Australia and the map of US. Similarly, Sudoku and crossword puzzles has also another CSP based problems, where the number which we fill in the Sudoku puzzle varies from 1 to 9, and there is a 81 cells, 9 by 9 box that we need to satisfy that each row and the column should have a unique 1 to 9 numbers and should not have same numbers on the adjacent columns. Like from the same row, we should not have repeated numbers between the 1 to 9, and it will applies from the each rows, each columns, and within the 3 by 3 square of box. Similarly, crossword puzzles also is a similar type of problems compared to the Sudoku, and similar problem based on the CSP is image labeling problem. The more complex and more real-time problems, we can say that constant satisfaction problem in the system optimizations and the resource allocation problem, which I have listed one common examples with the traveling salesman problems. Suppose if our requirement to work on the logistic arrangement of the system, where we try to minimize the cost of operating of the logistic systems by maximizing the delivery and customer satisfaction, then how we manage that resources to meet the if we need to do operate that logistic systems across this Europe. That same screenshot which I have put it, and these are the common examples which we find across the different books and paper and the research papers. So coming to the back to the CSP is built around the three main components, which we can call as the three pillars. They are variables, domain, and constant. What are that variables, domain, and constant? We will be explaining. I'll explain in the next slide. Okay, let's continue. CSP are mathematical questions. Questions defined as a set of variables. If we wanted to define CSP as a mathematical questions, then P is a set of x and d, which represents a CSP, where the x set of P is a set of xdc, where x is a variable which varies from x1 to x and depends on how many variables participate for the problems or entity participate to that problems. D is the domain, where is the what is the problem domain or the what is the constants and the variables play around the specified domain range. So the domain also will be number of domain, which we denoted as a d1 to dn, and the number of constants c1 to cn is a one set of constant. One constant is a composed of two or more variables, or one or more variables associated with a subset of the list of variables defined in the X. So in that context, now we have some idea about what is a variable and what is constants. Now go for one simple examples. In our childhood age, we used to deal with the identifying the age of the father and age of the son in the some equations, which I try to mimic here. So I denoted age of the father as AF and age of the son as AS. So now this is the variable where AF and AS are the two variables. So this is the two-dimensional problems like this. Then age of the father should not be equal to the age of the son if they are biological parents, right? So technically it's not possible. So this is the first constraint. Second constraint is age of the father should be greater than or equals to age of the son plus 18 digits. So this is the one assumption, based on the one assumption that normally one can be a parents after age of 18 only. So then this is the one another constant, and the next constant would be age of the father must be greater to the age of the son if they are biological. These are the three constraints which I define just to refer what would be the constraints look like. And the domain could be the each of the variable must be integer, and it should not be empty, and it should be greater than 0. So these are the domain which I have listed. Another one more examples with the CSP is a graph node coloring problem. This one graph which I have drawn here in the left side of the slide, where there are 4 nodes, and that means the variables which are participating these two problems is 4 variables. That name is 1 2 3 4 of the respective node name, and the domain D is the given set of colors which we need to apply to those available nodes of the graph by satisfying the given constraint. This is how we try to define the CSP. So in the constraint we say each adjacent node which is directly connected should not have same color, and that means one is directly connected to every node. So once we selected some color here, I selected red, should not have same color to any of the remaining nodes. So now going to the implementation with the backtracking techniques, how it works. First we'll try to find out the initial domain, what it could be the possible for all the possible color for every nodes. So we listed, because before giving any colors on the respective nodes, we can choose any colors. So all 3 colors will be possible for each node, and then once we selected the red color for the first node, then the possibility for other 3 node of 2 3 4, the color possibility is reduced to only 2, because the red cannot be applied to given nodes, other 3 nodes, because one node is directly connected to the other remaining 3 nodes. The next level we selected green color for the 2 node as we go from the left to right, and this is the least possible combination of color pendings, right? And then we selected green here, the possible, once we selected the green color and 2, then we have green and blue is possible for the third nodes, and the 4th node is still possible only blue. Now if we again follow the same techniques, follow from left to right, and then if you try to apply the blue color on the 3rd node, then we reach to the violating the constraint, because the moment we select the blue color in the 3rd node, the only possible colors in the 4th is blue the moment we given the green color in the 2nd node. So this is the illegal selection or the illegal moves where we violated the constraint. At this moment, at these situations, we will go to the backtrack techniques and to try to go back to the conflict state where that conflict will resolve. So from this state, actually this move was supposed to be different move, and then we intentionally try to apply this move, right? So now we go to backtrack to this move, and then where we can see that, okay, from here when we are trying to select the blue on the 3rd got conflict, so from here we can go to, actually we are supposed to go to the 4th blue, because after this we have here only 1 color possible here and 2 colors, so after that it should be go to the 4th node, and then here we selected a blue color for the 4th node, and then once we done that, we'll have only 1 possible for the 3rd node, that is green, and then the last steps we selected the remaining color, and we solved this problem by just giving the different colors by the set of 3 colors applied in the given nodes. This is very simple examples which I tried to explain with the constraint CSP logic. Now let's continue further, and this is one more common examples which we find in across the different books. So I have referred this book which I have referenced here. This book explains and implements different map coloring and the CSP related topic very details and implementation in Python as well. So this this how the Australia map, if we try to apply the three different color, how the starting and how it could be implemented, how it can be implemented, it has shown in the solution space, will be in the right side what I have put it in the slide. And then here variables which participate in the CSP problems is like a name of the province or state of Australia, and the domain is given color, and the constraints are like so adjacent province like Western Australia, Northern Territory, and the Southern Australia are the border adjacent border state where we must have a different color. In this place, in this situation, so the constant is every state which is touch its border should have different color. With that constant, we are able to apply the different color, and none of the states should be left blank, and every color should be used. Something like these three constants which we try to implement. So let's go further. And the problem is faced for the map coloring problems are for specific to only for Australia is not that big compared to the Sudoku, because here Sudoku has a problem solution space is 9 to the power 9, because 9 cells are there, we have to fill the 9 numbers there. Then the number of 9 to the power 9 is very big number. With that context, we can say like if we go for just try with the hit and trial option, we maybe end up spending a lot of time or memory or the system resources. If we do that, then we need to apply some techniques to minimize such operations which cost, which we cannot afford to go with the hit and trial. So CSP with the backtracking helps a lot with that. So now I try to explain what it could be the algorithm to explain. I have listed down here. This is the basic implementation algorithm for implementing solving the Sudoku with the CSP with the backtracking. So first step is isolating the empty cells. So we need to isolate the empty cells, means we need to figure it out what all the empty cells apart from the given number set which in the input Sudoku. So here you can see in the left side in this image the blank space which all are empty cell, and the which a number which already fill is the given number for which we'll be utilizing to help filling the other remaining number. So this is the first step, and second step is elimination steps, where here we will try to list the all possible numbers in the empty cells, what all the possible digits are in that particular each cell which are listed empty in the first step. Here if you see in the left to right rows and within this box, in this cell only 9 is possible. In this cells we have 4 digit 4, 6, 8, 9 is possible, and here also 4 digits are difference possible, and particularly this cell and this cell has apply on or the possibly only one digit is possible, that is 1 and 4. So now this third steps helps to listing down and putting those numbers which possibly fit. Then in the fourth step, try to choose the number, and in the second steps we do that, and the second step we isolating the single digit empty cell. So in the empty cell where we in the elimination step where we find the single digit cells, if you see here this one and this one which I mark in the yellow color, just simply go and select that number because the possible number is already we known. At this moment we'll reduce the problem solution space to more closer to the problem domain, right? The problem gap of the problem domain and the solution space is getting reduced, and then recursion of that looping or something, that techniques to iterating to scanning that approach will be get smaller. Then now in the fourth steps we try to choose the number within the 3x3 inner square and repeat the second and third of each rows. Now what does that mean? The moment we select this here 9 and 4 and 1 here, if you remember here, the moment we select this 2, 1 and 4, we cannot put the 1 and 4 in this cell. We just possible is 6 and 8 is possible here. 6 and 8 is possible. In the second iteration we will have only 6 and 8 is possible. Similarly, the moment we select the 9 here, we cannot select the 9 here, and the 1 and 5 same thing here. 4 cannot select, so here also possible is 6 and 8. So now this was having 4 possible values, now it reduced to 2. It goes, the same logic applies to every cell. So it says that we try to eliminate and select the numbers which are having during this process we will be keep on getting the single digit possible cells, and keep on repeat that steps of 2 and 3 until we fill all the numbers across the each rows and columns and every cells of within the 3 by 3 box of the Sudoku given box. So this is the one screenshot with problems from my mobile app of the Sudoku, and then how I selected 4 and 5 I given listed here within this blue color marking box, and the rows and then column how it looks in I mark in red lines. And the solution I have implemented this by using Python, and how I solve it, the implementation of that particular this particular Sudoku by using Python, which I will be showing at the end of the presentation. So the same program, I have solved 3 different Sudoku, and I put the same screenshot here. Now CSP we can use in the different problem domain, as I have earlier told. Here I try to implement in the Sudoku by using the lingo software by using the linear programming techniques, right? Here this is in the left side of this is the optimization problem, where objective function is maximizing the equation 3x1 plus 5x2. What is the possible value that can give the maximum value for this equation? This is the objective function, and the detail of the constants are listed below. This is the lingo syntax. Lingo is a software, and then once we put this constraint, we can solve this first equation, which I put it on this 1.1 questions, that we can solve it by using the lingo. And the solution what we've got it is value for x1 is 4 and x2 is 6, which gives them the possible best maximum values for that equation 3x1 plus 5x2. This also I can show you at the end of the presentation and by using lingo. And this is another example in the graph. If the problem domain having only 2 variables, like a 2-dimensional problems which we can plot in the graph, then constant satisfaction constant satisfaction CSP problem can be implemented in the graph as well, which I have done in the paper. This is paper-based graph, right? This I have done for the one of assignment at optimization. I kept it same thing here. So here one more interesting thing is, if you see here the problem is minimization problem, z equals to x2 minus 2x1. If this is the constant, this last constant is very crucial here, x1 comma x2 greater than or equals to 0. If it is constant is there, then the value of the solution space will be the solution is 4 comma 0. But if the value of x and x2 greater than 0 is not there, that last constant is not there, this subject to constant not there, then the possible value which minimize the value of for that equation is found in the 10.5 minus 6, which I have given in the plot here in the right side in the red color, you can see here. That means depends on the constant, the solution space and the value of solving the problems is vary. So constants we must obey or the satisfied during and even until we reach to a solution. That's what I was trying to say here. Let's continue further. So this is one of my real-time problems which I am trying to solve in my optimization subjects. This is as we know, this is the one example of the banking and financial institution where they try to maximize their earnings by minimizing their defaulter rates, the customer who cannot pay their loans in the bank and finance. So here these are this data I extracted from the one bank in Nepal. That data is in the 2018 data set. the balance sheet of the 2018. So their total interest on is approximately the number which I have listed here, and the fund which is available for lending activities which I have listed in the blue color. And then the cases are like there are four type of loan which the bank offers, and the respective rate of interest which I have listed here, and the respective probability of their failure of defaulter rates. Like the rate of defaulter is around for real estate loan, which is marked as a x, as a denoted as a x variable, which is 2%, 5% for personal loan, 6% for agriculture loan, and the 6% for the tourism loan, and 3% in the manufacturing loan. As you can see here, the interest rate for the manufacturing and the tourism industries are more, but the because the higher the earnings, there is a risk of more defaulter, because if the organization, the company, or the customer who took the loan, if they are not able to repay their lending money, then it's a risk for the bank. So it's this one set of implementations what I'm trying to solve by using the based on this constraint, which we can see in the left side. Now our objective function is maximizing the interest on interest income. What does that means is, as you can see here, 2% loan of the X is the real estate loan, which is 2% is a failure, then 98% loan, whatever we spend it, and the person loan get earnings should be 12% of 98% of the total personal loan, right, minus 2%. So this gives me the total possible earnings from the personal loan. Same thing we do here, and once we sum this gives me the total income under different lending sectors of that particular bank. With this objective function, try to find out the proper loan amount which we should choose, and on the different sector of the this portfolio, so that we can maximize their income earnings on the interest income. Along with that, we should see the defaulter rates, which should be very critical. If we invest more in the manufacturing, there is a chances of there is chances of here. You can see the default ratio for agriculture and the tourism industry is 6%, which is the most highest across the other sector. So what is the sector we should be putting those money distribute equally, so that our income will be maximized and the risk of getting defaulter will be minimized. So this is the problem of really real-time problems which I'm trying to solve. Technically I still doesn't have any solution for this. I wanted to solve, and I am trying to implement in genetic algorithm or the linear regressions. If anyone has some idea, they can share me. I'm happy to hear from anyone. I am still trying that one, so but still doesn't have solution. I just put this information I extracted from their balance sheet and listed here as a constraint satisfaction problem. What it could be the problems it in the real world. So as you can see, there are number of constraints is listed here. Some constraints are regulatory constraints, like a government or the central bank, which impose to the every bank. The common examples, like their personal loan should not exceed the 10% of their total loan. And the other simple one more constraint is their real estate loan should not exceed 25% of their total loan. And similarly, here one more constraint is here. They to diversify their investment, they should invest. They cannot say that I will not spend the money or lend the money on the tourism sector because it's higher in risks. They cannot say that. Minimum 5% should be lent, and they can decide the maximum what it would be that. So depending upon this constraint, so you can see the constraints is mandatory constraint, optional constraints, something like this. And then as we know, the number of loan and interest offered by the banks vary in the very big number. And then this variable which participate in this CSP problems are a lot. And when we try to solve these problems, in the software like lingo, we get insufficient infeasible solutions or infeasible problem because it cannot give that solution space what technique it has implemented. So I just try to explain on that. Let's go to some demo which I have implemented Sudoku implementation and lingo for the example which I have presented. Let's go here. Okay, first let's start with the my Sudoku problem which I have implemented using Google Colab in the Python. So here as we can same given instructions how I implemented, I have put it here. And then if this is the input cell where you can see each 0 is a empty cell, there each empty cells are represented here is as a 0, and other now digit which it's already populated between 1 to 9 are the given pre-filled number in the Sudoku. And then same here, once we run our program, it prints the solution space like this in the little bit Sudoku style formatting. Now it takes the input like this, and first it prints for printing logic how it prints, and then if I run here, so it printed here same thing. And then now I have earlier explained basically three steps involved in the solving. First we isolate the empty cells, as you can see here, isolating the empty cells, and then we backtracking and repeat that logic until we resolve the problems of validation and the solving. As we know that once the moment we say backtracking, or it involves some kind of recursion. So this Sudoku solver is the one method which keep on calling this validation and Sudoku solver. So it until it solve all the identified numbers. So let's go to validation steps. This checks the possible numbers across the each rows, and this iterations I try to make it solution as simple as possible. So as you can see, this second loop is done for each column, and this last iteration is for identifying the possible number and eliminating that number within that possible from the possible combination of number within the 3x3 inner box of the cell, which that means is this small one, this left side, the square of that inner, and that 3x3 box, total 9 box present in the Sudoku. Let's execute this program, and then this is the input which if we are passing here, and I try to earlier also I have run, now I'll be running, and I try to calculate the what time it took. First it took this input array, and I copy the deep copy so that it will not change the input arrays. I call for first print, and then second I call the solver, and it will iterate it will call say this method to solve the problem by itself in the recursion, and once it's solved it will return and then print what it has solved for us. Let's try. So this is the input which we pass from here, and the solution space for that problem is this. If you remember here, this is the same problem, same number which I have printed on this in the this one. This is the same Sudoku number I have input, and the solution space printed here. So now if it's, you can see here, it takes around 3 seconds, less than 1/3 of second, something like that second it's solved. So and the same thing goes to here, another it takes this, and solution space it is this, and it takes this as input, and the same thing I have put it in my presentation. So now this in this way this is very simple, and I implemented for solving the program. It works for specific input of Sudoku, because if we have a different set, if we wanted to supply different Sudoku style, then we might need to write a different implementation. Here you might have seen the 0 as a empty cell, but 0 is the number, but my assumption is because the number which we fill in the Sudoku is 1 to 9, and the 0 means is not a valid number, and that represents the empty cell. That's what my assumption, and we have implemented. Now I'll try to see it for the lingo implementation. This one. So let me load the problem which I have explained in the site. This is the same problem, and this is the objective function, and these are the constraint, and this is the lingo syntax. On lingo we need to give terminate every statement with a semicolon, and once we have a proper syntax, once we click here, this gives the solution. It gives the detail of how it solved this problem and what are the things it employed. The model class, it's a linear programming techniques it use, and the state is global optional, and the objective is 42. It gives the detail, and then constants are like total 7 constants are there, and the total variables are the 2, and these non-zeros are 10, and the generator memory use something to 23 kilobytes seems it use. And then after this, as you can see here, it lists the values of the solution for the x1 and x2, which will be gives the maximum values for this equation x1 and x2, that gives the satisfying the maximizing the objective function. So that's all from my side here. Thanks for listening me, and if anyone has questions, I'll happy to answer. I'll uploading this video as well as this my notebook, and as well as this presentation in the Drive and YouTube and in the Facebook. Thank you so much.